Hello everyone, this is Mr. Kalab from Complete Chemistry by Kalab. Today we're gonna do an experiment from Cambridge International AS and A-Level Chemistry, Advanced Practical Skills 1 of the May-June 2024, paper 3-1. We're going to do question number 2. Okay, this question is to determine the integer value of x, meaning water of crystallization for sodium sulfides. Okay, for this we're going to do a redox titration to determine the amount of the water of crystallization for sodium sulfides. Okay, so what we're going to do is let's begin by making sure everything we need is in our table. Okay, so for these experiments we need to have three chemicals. The first one is Fa5. This is iodine solution prepared as instructed on the paper. This is Fa4, solution of sodium thiosulfides, again prepared as indicated in the paper. And then we have Fa6, our indicator. This is starch solution, which will be used for the indicator in our redox titration. When it comes to the apparatus, here we have, as you can see, we have two small beakers, one for Fa5, one for Fa6. Here I have my wash bottle to rinse my burette and stuff. Here I have my pipettes. This is used to measure or take out accurate volume of a substance from its container. Okay. Here I have my conical flask to do the titration, and then here I have the most important apparatus here, which is the burette. Okay, alongside with the burette I need to have a funnel so that the transferring of liquid is safe. We don't spill anything to ourselves. Okay, good. Let's begin with reading the instruction and then we'll do the experiment. Okay, so the method or the procedure says the first step is to fill the burette with Fa4. I'm going to fill the burette with Fa4 and then to pipette out 25 centimeter cube of Fa5 into the conical flask, and then to add drops of the indicator. Okay, but we first what we need to do is we need to be very cautious with our, or very comfortable with our burettes. So let's check if the burette is working properly. Okay, by working properly means we can or it has to be easy for us to add drop wise, add in excess, and then close it instantly. Okay, now let me check. Open. Okay, drop wise addition, perfect. Close at an instant time. This is good. Now let's take all the water out. Nice. Let's begin with our experiment now. So the first step is to fill the burette with Fa4. So I'm going to pour some amount of Fa4 into this small beaker so that it is safe for me to transfer. Okay, I don't want to spill any of these substances into my hands or other part of my body. Okay, before filling the burette with Fa4, I have to rinse it first. Okay, so I'm going to use this. I'm using this as a dustbin, we can say. So this is Fa4, sample of Fa4 I have taken from this container. Okay, now let me take this one out to make sure that there is no any other impurity inside our burette. Okay, perfect. Now let's make this close. Good. Take the last drop out. Nice. Let's begin our procedure now. So the first step is to fill the burettes with Fa4. Do I have enough Fa4? Make sure you are gentle when filling the burette. Okay. Okay. Now this is a little bit higher than 0, so I need to take this excess amount out first. Yes. Now this is exactly at 0. Make sure that your table is clean, okay, all the time. You have to maintain the sanity of your table. It makes your work pure as well as it appears good. Okay, so let's begin our titration now. Now the first step to do is to record the initial volume, okay? So this is 0. For my rough titration, the initial volume is 0.00 centimeter cubes. The second step is, okay, the second step is to pipette out 25 centimeter cube of Fa5, to pipette out 25 centimeter cube of Fa5 into the conical flask, okay? So I don't want to contaminate my sample here, so I'm going to take some amount out into a small beaker. Good, safe and sound. Okay. Now I'm gonna use my pipettes. Let's take the air out. Nice. Now let's measure exactly 25 centimeter cube, okay? So this is a pipette which can measure 25 centimeter cube of liquor sample. Exactly, okay? Now let's take this into our conical flask. So now you see a drop of liquid is left here. It's okay. It's known, it's considered, okay? Good. Now let's proceed to our experiment now. What you're going to do following this is we're going to titrate this until yellow color appears, okay? This is, as you can see, reddish brown color. So after certain amount of or certain volume of our F4 is added to here, we will see yellow color appearing, okay? So you have to be very careful. You have to stop instantly after the first red color appears, yellow color appears. So you don't need to stop shaking or swirling the mixture. Yeah, little drops. Need some amount. Yeah, done. Perfect. So when I see it down here, it's yellow now. Good. Let's continue with our procedure. The third procedure says add 10 drops of Fa6 into the conical flask. Okay. Let's add 10 drops of Fa6 into the conical flask. This is Fa6. One, two, three, four, five, six. I need to add four more. 7, 8, 9, and 10. exactly. Okay. Now look at the dark color here. So our end point is the disappearance of this dark color. Okay. So let me continue to titrate till this dark color disappears. Yes, we've got it now. Okay, the final volume for the rough titrate, let me read from a white background, is exactly at 21 centimeter cubes. Good. So let's recreate 21.00 centimeter cubes. So now volume used for the rough titrate would be 21.00 centimeter cubes. Good. So this is our rough attempt or the first titrate. So we're going to carry out these experiments for at least 2 or 3 times until we get our concordant results. Okay, so let me show you one more and then we will see if you get a concordant result. Okay, let's add some amount of Fe4 into our burette. Let's make sure this is closed. Good. So remember, it doesn't have to be necessarily or exactly at 0. If you have enough amount, you can use that. Okay, now okay, let me take my reading here. This is exactly at 10.00 centimeter cubes. So this is going to be my initial volume, 10.00 centimeter cubes. This is going to be my initial volume for the first accurate titration. Okay, and then let's repeat all the way. Let's repeat all the process again. Let me pipette out 25 centimeter cube of Fa5. Okay, good. Now let's press E. Okay, let's do the experiment again. Let's start our titration now. Remember the end point is permanent yellow color. Little drops. Now we can tell that this is yellow, okay? From my side, this is yellow. You have to see it through, okay? Good. Now let's add our drops of indicator. 10 drops of this starch indicator. 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, and 10. Good. Now we're going to continue with our titration till all this dark color disappears, okay? Good. Now the dark color has disappeared. Let's close. Good. Now let's read our final volume. Let me take this a little bit up. Okay. Let me read it from a white background. So this is exactly at 30.2. So V final is 30.20. Now let's calculate the volume used for the first titrate. 30.20 minus 10.00. This would be 20.20 centimeter cubes. Good. So this is the first accurate titrate. So we're not going to do any more titrations, but I'm going to tell you how we're going to proceed, okay? So you are expected to do at least 3 titrations, but if you do not get concordant titrates, you can continue doing so, okay? What does concordant titrate mean? And 2 or more titrates with a maximum difference of 0.1 centimeter cubes, okay? So for example, our first accurate titrate was 20.20 centimeter cubes, and then if the second titrate is like 20.30 or in between 20.20 and 20.30, that means our titrates are concordant, okay? Nice. So this is enough for the practical parts, and in the next video I will show you how to draw your tables to record your rough titrates and your accurate titrates, and then I will show you how to do the calculations for this question. Thank you. See you in the next video.